This is a 10-watt laser module and it has no problems cutting through wood. This is not a toy. That would be very irresponsible if you're going to This is not good. In one of my earlier videos, I've shown a 3D printer controller that I've developed using LabVIEW. LabVIEW is a graphical programming interface which is very good at controlling instruments. And I think I came up with a fun application for this 10-watt laser engraver. If I press this large draw button, you're greeted with this graph, with an XY graph. I can just draw within this XY graph. LabVIEW is just catching the actual position of the mouse, this fun part. In real time, it generates the G-code. For those who don't know, G-code are quite simple instructions used for controlling machines, like 3D printers or laser engravers, milling machines, lathes. I'm using Lightburn for controlling a laser cutter. I just looked at the G-code generated by Lightburn and did the same thing in LabVIEW. And it gets even cooler. I've got this tablet with a pen. It should be possible to just draw on here and have the laser cutter do the exact same thing. Just replicate the movements I'm doing on this tablet. In a video about a 3D printer controller, I also made my own drivers, my own LabVIEW drivers. And I think that these drivers can just be implemented into this program. I haven't done it yet. I only made this to see if this drawing actually works. I have no idea what is going to happen. The laser cutter I'm going to use is this Pergear LaserStorm S10. I've done some modifications to it. First one is this base plate. I just went to a local hardware store and they cut it to the right size. And now I have a fixed base, always parallel to this laser engraver. Normally you just put this at a flat table, but I've also added this fan duct with this vacuum tubing, and I can connect this to the fume extraction system that I've made in an earlier video when I was playing with solvents. Well, playing is not the right word. When I was experimenting with solvents, this keeps the size to a minimum while being relatively safe. And I've also bought some safety goggles, some better safety goggles than you usually get. I've bought these from JTech Photonics. This has a protective glass here at the front, but in my opinion is a bit similar when you're standing behind a conventional lathe and saying that this is enough not to wear safety goggles. You have only one pair of eyes. Okay. If I start the software, then it should initialize and then we should be able to draw with it. I have my finger to the emergency stop button, going to select draw. Here we go. It should work. Okay, again, initialize and start drawing. It did so. It doesn't home, so why not? Doesn't it have a homing sequence? Okay, I'll just manually place it into its homing position. Run this again, draw, and somewhere here. What are you doing? It's going back every time to its zero position. What? It does something. Oh wait, okay. Where are you going? What just happened? Okay, I'm going to find out what this thing is actually doing. I will manually connect to it through a terminal and send the codes manually to see how that thing actually reacts to a command. I expect that if I will send G28, that it will home. G28, enter, and it doesn't home. So why not? I'm going to send these commands with I will just send what I started G-code with 00 and G17, 21 and G90. Still not doing anything weird. Good. And then the actual movement start. Oh, we go G0. I first have to, Y10. That's not doing much. Oh, I will just include the speed and the power of the laser. King hell, why doesn't this stupid... it turns out you have to disengage the emergency button. Fuck me. Hey, we have some text here. G28, please home. And it... Fuck my... How do you home a laser engraver? Laser GRBL. Homing, come on. You have to move after homing. To have sure stored that. Is this the homing cycle? this command here? We can try. So shift 4H. Fuck yeah. Okay, it's not G28. I'm going to do a few tweaks in LabVIEW and then it should just work. I've done some minor tweaks with the newly gained knowledge. So let's see if it works. One of the newly gained knowledge is that I have to disengage the emergency button. Okay, draw. Come on. Hold this a bit differently. Don't need this one. I don't care too much about this yet. I don't need that anymore. Please work. Yeah. It's homing. Okay, come on, draw. Yes. Another line. Look at this. This is my scribble. And it's just cut out of cardboard. So if I don't do the homing sequence at first, then it would go immediately after I've drawn. I move it manually to its homing position. Delete element. Okay, now it's not going to home. Yep, okay, and now it's mimicking my movements. Okay, now lower to the left, to the right. Okay, this is sick. I'm going to let it do circles. Man, if you're a tattoo artist, you should pay attention. I'm going to install this on my tablet. And another cool thing, hopefully that works. Click run, then it should do the exact same thing again. No, it doesn't. I'm going to install this on my tablet. Let's draw, maximize this. Well, let's make a drawing. Oh yeah. Okay. This is actually sick. Subscribe. I can draw with a laser engraver. How awesome is that? The only test that we've done so far is at 10%. Now it's at 100%. Let's see what happens. Okay, besides being useful for tattooing or advanced brain surgery, what else can we use this new developed technology for? Ja, goeie vraag. I'm curious if it would be possible to set something on fire. Okay, it's at 100% right now. And I'm going to reduce the speed to, let's say, 500. Let's see what it does to this piece of cardboard. What? Holy shit. Yeah. Oh, it's still burning. Wow. Oh shit. Oh man, this is not good. Whoa! Whoa! This is definitely not a clean cut. Wow. Also an interesting way to test my fume extraction system. Check this. It's glowing red hot when the fume extraction system comes close. Wow! I think that this 10-watt laser engraver is a fire start. Can we also do something useful with it? I've made this extruder. This thing is already capable of 3D printing a guitar neck. And it has an interesting shape, and I think it would be cool to design packaging for this thing. And with this laser cutter, we can create fitting packaging. Using packaging, I've designed a simple shape, and I can export this part as an STL file and import that into a slicer called Slicer for Fusion 360. This program sucks, it's no longer being maintained, but it works. Once everything is tuned in, you will end up with the same part but sliced. And if you go to get plans, we've got the plans to make this part out of cardboard. We can export this as a PDF file and import that into Lightburn. Select which page I want to use, and we have to do some post-processing. We don't need this. We don't need the numbers. It's just a different cut, so I can just deselect it. It adds these small squares. You don't want that. I've prepared a couple of slices. So what I have to do now is slice the rest, which is the interesting part. And then we have to cut ourselves the actual box which goes around. And I found a cool website which has a ton of templates for cutting out boxes, but I will show you that a bit later. The nice thing about using this wooden base is that I was able to cut my own grid on here, so it's way easier to position my part. I've cut out all slices, but now we have to make ourselves a fitting box for it. I found this cool website called templatemaker.nl, and you can select between a lot of different shapes. I can enter the dimensions here and it will change accordingly. If I change this, the shape will change as well. I'm going to export this as an SVG file, and I can import that SVG file in Lightburn again, and it just fits on the build plate. Turn this off. And we are only left with this outline. And now we can cut ourselves a box, fold it, and hopefully everything fits. It's only a bummer that this sheet of metal is too small. I have to carve my base plate. This cardboard is large enough. I don't have to position it that carefully. I really do have to make this fan duct a lot larger because there's still smoke everywhere. I think it would be better to use thinner cardboard, but I don't have that. This is a pretty tight fit. I'm going to glue this thing together. I think I've got another option. I recently received this flexible build system from Wham Bam, and it has a nice large sheet of thin cardboard. Okay, that's already looking a lot better. Nice. I must say, I really like how these cardboard layer lines look, and this extruder also fits very well in here. And now I've designed my own packaging. In one of my first videos I show how I cut out a butterfly out of XPS sheets. And this is used for subflooring. Even that tiny laser module was capable of cutting through this. I still use this stuff for the names of my top tier Patreon supporters on the wall over there. With the 10 watt laser cutter it goes a lot faster. I think that this is an interesting use for a laser cutter. You can put your own sign on the wall like live, laugh, love or home sweet home. Special thanks to these guys, my top tier Patreon supporters. Your support helps a lot with these projects. I've got also new merch, and this heart is the actual front view of that extruder that we just made a packaging for. If you have a cool use for a laser cutter yourself, then leave a comment. I'm very curious what you guys come up with. And for this video, this was it. I hope you liked it and see you in the next video. Bye! Oh ja, misschien nog even voor die extruder.